So we're going to take a look at the volume of cones and kind of how to use that formula, what it is, and how it relates to a cylinder, because that's the main key here about how to understand the volume of cones is how it relates to the volume of a cylinder. So going back real quick to a cylinder, remember a cylinder is two circles that are connected together, whereas a cone is one circle that's connected to a point, either above or below the circle. So it's kind of like a circular pyramid, whereas a cylinder is kind of like a circular prism. Now to get the volume of a cylinder, we had this formula here, pi r squared h, where r was the radius and h was the height. You plug your r and h in there, multiply it all together, and you get the volume. Well, the thing about a cone is that if you have a cone that is the same height and the same radius as a cylinder, like the two shown here, if you take 3 scoops of that cone, it would fill that cylinder completely. So it takes 3 scoops, and remember scoops is a sort of volume measurement because you're filling the inside the cone. If you take 3 scoops of a cone and pour it into a cylinder of the same height and radius, it will take you 3 of those scoops to fill 1 cylinder. So what that means in terms of the volume is that for the volume of a cone, we start out much the same way, pi r squared h. But because it takes 3 of these to fill 1 cylinder, we're going to take our cylinder formula, which we had written here, and we divide it by 3. And that is how we get the volume of a cone. We take pi times the radius squared times the height and then divide it all by 3. Some will write it like this as well. There's another version, so I'll put an or here. It says 1/3 pi r squared h. So another version of the formula that does the exact same thing, just a little bit different way of writing it. If you multiply by 1/3, that is the same as dividing by 3. And there has to be one little caveat here, one little thing you have to look out for when you're doing this cone stuff here, is that unlike a cylinder, a cone, they may give you a little bit more information than you need. So if you see here, we have the height right here in this cone, and of course the radius. Now notice the height goes from the tip of the cone to the circle. That is always going to be the height. It's called the true height there. You go from the tip of the cone to the circle. The slant height is this little diagonal piece here. So we call it the slant height for obvious reasons. That is basically the height or the distance you would go if you stood on top of the cone and slid down the side. We call it the slant height. That is used for the surface area of the cone, but it is not used for the volume. So you have to be very careful about the pictures they give you or the diagrams they give you, because sometimes they will throw in a slant height as well. So you'll have 3 numbers you're looking at. You have to make sure that if you're doing volume, the only height you're concerned about is the true height, the one from the tip to the circle. Okay? And you usually be denoted as a right angle mark. As we see, we have a right angle mark right here. You have to look for that if you're confused. But again, the whole idea here is that the slant height is not used for volume at all. It is simply the true height, tip to circle, and the radius. That is what you use for the volume formula. So let's take a look at how it's applied in a few examples here. So we have a basic cone here. We have a height of 20, clearly it goes from tip to the circle, so that is our height. Now in this case, they give us the full distance across the circle, from edge to edge through the center. However, we don't need that distance. All we need is the radius. So remember, the diameter is the line from edge to edge through the center. The radius is simply the line from the center here all the way to the edge. That's the distance we need. So what we're going to do is we're going to take our diameter, we're going to cut it in half, and we'll get our radius of 6. So every now and then you have to be careful, even with cylinders, to look out and make sure they give you the radius, not the diameter. So we're going to go back to our formula. We're going to plug in our numbers. So r is 6, h is 20. 6 squared times 20 all over 3. Now again, it doesn't matter what order you do this in really. You can do 6 squared times 20 divided by 3 times pi. You can do 6 squared times pi times 20 divided by 3. The only thing you really have to worry about is to make sure you do the squaring first. So you have to do 6 squared first before you do anything else. But other than that, it doesn't matter which order you take it in. So I'm going to say 6 squared here, that's 36. So now I can multiply and divide in any order I want. So I will do 36 times 3.14, which I'll use as my substitute for pi, times 20, get that answer, and divide it by 3, and I end up with 753.6 in cubic centimeters. Again, if you don't believe me, you can go ahead and try it on your own. Do 36 times 20, then divide by 3, then times pi, then do 36 times pi divided by 3, then times 20. So go in as many orders as you want. As long as you do 6 squared first, you will always come out with the same answer. Okay, so order does not matter as long as the squared gets done first. So again, very similar to a cone, or sorry, very similar to a cylinder, my bad, in that it's just plug and chug. Okay? And the formula is not too drastically different either. Let's take a look at another one here. So this time my cone is a little bit sideways, but we still do the same thing. The height is from the tip to the circle, so this h right here, that's my height. It's going from tip to circle, so that's how I know it's my h. And then 4 would have to then be my radius, only the number left. So I go to my formula, pi r squared h. I'm going to put in my numbers. Oh, sorry, divide by 3. I'm going to put my numbers, pi 4 squared 8 divided by 3. And then again, as long as I do 4 squared, which is 16 first, I can do the rest in any order I choose. So I'll do 16 times 8 times 3.14, and then divide that by 3. And I get 133.97. If you want to be really exact, it'd be 0.973 repeating. Again, that bar means the 3 goes on forever and ever and ever and ever and ever. So that's our volume formula for a cone for those 2 examples there. Again, as long as you can identify your R and your H correctly like you can with cylinders, then it shouldn't be that big of a deal. Just be on the lookout for that slant height every now and then if they choose to give it to you. Now, just like with cylinders, you can go backwards in this formula as well. So you can figure out your R or your H if you're given your volume. So what that might look like is something like this. So we have an ice cream shop that wants to make an ice cream cone that holds 100 cubic centimeters of ice cream. And if we're going to set the 10 centimeters as a diameter, what do we need the height to be? Well, let's make a diagram here real quick. Here's my diameter. We'll say that's 10. We draw my cone. Again, I'm not the best artist, so you don't have to be either. I'll just try and draw a little bit of fancy stuff here. So there's the ice cream cone, if you can imagine that as an ice cream cone. And then we have 10 centimeter diameter. We don't know what the height is. So from the tip of the cone to the top of the circle, I don't know what that height is. I'm just going to label that as h. But I do know that my volume needs to hold 100 cubic centimeters. My volume has to be 100. So I'm going to go to my formula, V equals pi r squared h all over 3. And I'm going to start plugging in the numbers that I know for the variables that I know. So looking at the diagram here, I know that V is 100. So I'm going to plug that in for V. Pi is going to stay pi, no problem there. I know that 10 is not my radius, 10 is my diameter. So I want a radius, which means I'm going to have to cut 10 in half. So my R would be 10 divided by 2, which is just going to make it 5. So it'd be 5 squared here, times h divided by 3. Again, I don't know what h is, so I'm going to leave it as h. Give myself some space here. And I'm going to solve for h. So the first thing I would do is get rid of that divide by 3. Remember, my goal is to get h by itself. So I want to get this variable alone. So I want to move everything that's not in that box to the other side. I want to move everything away from the h. I want to isolate the h. So I'm going to start by multiplying by 3 and by multiplying by 3. This right here would give me 300. This 3 and this 3 would both cancel out. So I'm left with pi times 5 squared times h. And then now we're back into cylinder territory. We did this very similar thing here with cylinders last time. We're going to get rid of the pi 5 squared all in one go by simply dividing by pi 5 squared in total. Same thing over here. Divide by pi 5 squared. So the pi's would cancel, the 5 squares would cancel. I'll be left with just h. And in my calculator, I would do 300 divided by pi times 5 times 5. Or you can do divided by 25 because that's what 5 times 5 is. So if I type that in real quick, I get a height of about 3.82. So the height of my cone, ice cream cone, would have to be 3.82 centimeters to have a volume of 100 with a 10 centimeter diameter or a 5 centimeter radius. So just like with cylinders before, we can go ahead and solve for the missing pieces if we're given the volume by kind of reverse engineering the problem. We draw a diagram, figure out what pieces we have, figure out which piece we're missing, plug it into the equation, and then just kind of backtrack our steps. Hope you enjoyed the video. Have a good day.